Okay, today we're going to talk about solving radical equations, and we're going to look at square roots and cube roots and even higher indexes of radical equations. And just like we did on Friday, for a little bit, we're going to look at three different representations. We're going to look at solving with a table, solving with a graph, and then solving algebraically. In order to fill in the table, I like to graph first, so let's start there. I'm going to go ahead and label my two functions. I'm going to call the square root of b minus 1, y1, and I'm going to call y equals 3, y2. So if I graph the square root of b minus 1, that is a translation to the right. Oops, sorry, it should be in red. That is a translation to the right 1. So I'm going to think about my square root parent function, and I'm going to shift each point to the right 1. And that would be our graph. So let's fill in our table. If I plug in 1, I get 0. If I plug in 2, I get 1. If I plug in 5, I get 2. And if I plug in 10, I get 3. Okay, if we graph the line y equals 3, that's a horizontal line. Sorry, it shouldn't be dotted. That's a horizontal line at the y value of 3. Now I know how I drew my graph, it kind of looks like they crossed here, but in reality we know these graphs cross right here. So the y values of that second function are always going to be 3. And the solution is the point where the graphs cross. So that's when b or x is equal to 10. Or in a table when the y values from the two equations match up. So again, that's when b is 10. Let's look at it algebraically for a moment. If I set up the square root of b minus 1 is equal to 3, my first step to solve would be to square both sides. I would end up with b minus 1 equals 3 squared, which is 9. And I would add 1 to both sides, so I would get b equals 10. So no matter which method I used, I saw that b ended up equal to 10. Obviously, you don't have to use each of these methods every time, but it's important to understand how to kind of rotate between them. So we're going to do one more using all three methods, and then we will focus on algebraically. So this time our equation is 2 is equal to the square root of x over 2. 2 is equal to the square root of x over 2. So I'm going to start by graphing the y equals 2. I'm going to let that be y1. We know that that is a horizontal line with a y value of 2. Okay, and now let's graph the square root of x over 2. Now I can rewrite this as the square root of 1/2 x, which means that this 1/2 is a horizontal stretch by 2. So what that means is that I take each x value and I multiply them by 2 from my parent function of y equals the square root of x. So that tells me that my point at 0, 0 does not change. But my point at 1, 1, if I multiply that x value by 2, that's going to become a point at 2, 1. My point at 4, 2, I have to multiply my x value by 2, so that becomes the point 8, 2. And I could keep going. 9, 3 would turn into 18, 3, but that clearly wouldn't fit on my graph. So I'm going to go ahead and connect these. And let's see where they cross. They cross at this point right here, which means my x value is my solution, so that's at x equals 8. Okay, let's see what that looks like on the table. If I plug in 0, I got 2, of course, for the first function. And then for the second function, I got 0. If I plug in 2, I got, of course, 2 for the first function and then 1 for the second function. When I plug in 8, I get 2 for the first function and 2 for the second function, which tells me that this is my answer right here. Again, that x is equal to 8. Let's go ahead and try this algebraically. I have 2 equals the square root of x over 2. I would start by squaring both sides. So I would get that 4 equals x over 2. Multiply both sides by 2, and I get that x equals 8. So again, no matter which method we used, we get the same answer. All right, let's focus a little bit more on solving algebraically for now. I have the square root of negative 8 minus 2s is equal to 0. Now, I want to get rid of this radical, and in order to do that, I can square both sides. That only works once the radical is isolated, which in this case it is. So I'm going to go ahead and square both sides, and we know that 0 squared is 0. So I get negative 8 minus 2s equals 0. Negative 2s equals 8, and s equals negative 4. Now, with square roots, we know that there are domain restrictions. So it's really important to check that our solutions actually satisfy the equation that we were given. So you have to go back and check. So let's do that. I want to know if the square root of negative 8 minus 2 times negative 4 is in fact equal to 0. So that gives me the square root of negative 8 plus 8, which is 0, and does that equal 0? Yes, it does. So that means my answer is confirmed. All right, let's try this next one. 7 times the cube root of 5x minus 7 equals 84. My radical is not isolated yet, so what do I have to do first? I have to divide both sides by 7, and I get that the cube root of 5x minus 7 is equal to 12. My next step to get rid of this cube root would be to square, or sorry, not square, but cube both sides. Raise each side to the third power. So I end up with 5x minus 7 is equal to, now I don't know what 12 cubed is. That would obviously be something I would let you use your calculator on. So if you type that in your calculator, you get 1728. Then of course I would add 7 and divide by 5. This is a cube root function, and I know that a cube root function does not have domain restrictions. So I don't have to check for extraneous solutions on cube root functions. Only if it's square root, fourth root, sixth root, anything with an even root. All right, flip your notes to the back page. I've got x plus 8 to the 1/5 power is equal to 2. Now, from here, you might recognize that you could raise both sides to the 5th power and set it equal to 2 to the 5th power. The other way to think about this is rewriting this as a radical. The 5th root of x plus 8 is equal to 2. Well, just like I get rid of a cube root by cubing both sides, I'm going to get rid of the 5th root by raising both sides to the 5th power. So I get x plus 8 is equal to 32, which is 2 to the 5th. Subtract 8, I get x equals 24. This is an odd index, an odd root, a 5th root, so I don't need to check for extraneous solutions. All right, at number 6, you might notice that this time we have x's on both sides. And that just adds a little bit of an extra level of work. First, I check that my radical is isolated, which it is. So I'm going to go ahead and square both sides. So when I square the square root of 2x plus 14, I just get 2x plus 14. And then I get x plus 3 squared. Remember, you are not allowed to distribute this 2. You have to multiply out x plus 3 times x plus 3. Or you can remember our rule that a plus b squared is always a squared plus 2ab plus b squared. Don't let yourself fall into this trap of saying x squared plus 9. So I get 2x plus 14. When I double distribute this out, I'm going to get x squared, and then I've got 3x and 3x. That gives me 6x. And then I have 3 squared, which is 9. Now, if you'll notice that what we're left with is a quadratic. So in order to solve quadratics, we get them set equal to 0. So I'm going to move everything over to the side where the x squared is positive. So I get x squared, subtract 2x, plus 4x, minus 5. If you'll remember, the easiest way to solve a quadratic is by factoring. And this, in fact, does factor. We need factors of -5 that add up to +4. So that would be x plus 5 and x minus 1. That gives me the two solutions, x equals -5 and x equals 1. But I am not done yet, especially when you have variables on both sides. It's even more important to make sure you check for extraneous solutions. And remember, what extraneous means is that even though you solved everything right, that solution does not make your original equation true. All right, well, let's start by plugging in the -5. So I would have the square root of 2 times -5 plus 14, and I want to know if that equals -5 plus 3. 2 times -5 is -10 plus 14 is 4. The square root of 4 is 2, and I want to know, is that equal to -5 plus 3, which is -2? Well, 2 does not equal -2, which means x equals -5 is an extraneous solution. All right, let's check 1. The square root of 2 times 1 plus 14, I want to know if that's equal to 1 plus 3. Well, 2 times 1 is 2, plus 14 is 16. Square root of 16 is 4, and is 4 equal to 4? Yep. So x can equal 1. So that's our only solution in that case. Okay, let's try number 7. X plus 3 equals the square root of 7x plus 15. My square root is isolated, so I'm going to start by squaring both sides. And I just did x plus 3 squared. It's x squared plus 6x plus 9 equals 7x plus 15. Again, we have a quadratic, so get everything over to the side where x squared is positive and set it equal to 0. So I get x squared plus 6x. Not plus 6x. If I subtract 7x, I'm going to get x squared minus x. And then subtract 15, I'm going to get minus 6 equals 0. This factors as x plus 2 times x minus 3 is equal to 0, which gives us solutions x equals -2 and x equals 3. But we are not done. We have to check. It's really, really, really important. So let's start with the -2. -2 plus 3, I want to know if that's equal to the square root of 7 times -2 plus 15. Okay, let's see. -2 plus 3 is 1. 7 times -2 is -14, plus 15 is 1. And the square root of 1 is 1. So even though x equals -2 is a negative solution, it still ended up working here. That's why you have to check every time. Let's check 3. 3 plus 3, I want to know if that's equal to 7 times 3 plus 15. Well, 3 plus 3 is 6. 7 times 3 is 21, plus 15 is 36, and the square root of 36 is 6. So in this case, both our answers ended up being solution, and that's just fine. Okay? I want you to take a sec and go ahead and work number 8. I'm going to work it on the screen without talking, so I don't want you to look up. I want you to work it yourself and then look up and check your work when you're done. So as you worked this, hopefully you got down to your solutions, x equals -8 and x equals +7. When you plug in -8, you get that the square root of something is equal to -8. Well, we know that the square root of anything is never a negative number, so I could go ahead and cancel that one out and say that it's extraneous. You need to show me that you found x equals -8 as one of your potential solutions, and then I need to see it crossed out in order to receive full credit. And then when you check 7, it did work. All right, we are going to skip 9 and 10, so you can go ahead and cross those off. And let's look at number 11 on your notes. Remember that the first thing I have to do before I do anything, before I try and square and raise anything to a power, is isolate my radical. And notice that this is being raised to 1/2, so this is where my radical is, right here, this 3x minus 11. So I'm going to subtract 5 first, so this is x minus 5 equals 3x minus 11 to the 1/2 power. When I get rid of the 1/2, I'm going to square both sides. That's like taking the square, because this is the 1/2 is just like a square root. So I'm going to go ahead and square both sides. If it's easier for you to visualize this and rewrite it as a radical, go ahead and do that. That's perfectly fine. Okay, so let's think x minus 5 squared. So x times x would be x squared. We would have minus 5x, which gives me minus 10x. And then minus 5 times minus 5 is plus 25, equals 3x minus 11. Get everything set equal to 0, so we're going to move everything over here. X squared minus 13x plus 36 equals 0. Let's think about how that factors. We need factors of 36 that add up to -13. That would be x minus 9 and x minus 4, which gives us the possible solutions x equals 9 and x equals 4. So from here, we must check our work. I'm going to plug 9 back in. So 9, I want to know if that's equal to 5 plus 3 times 9 minus 11 raised to the 1/2 power. All right, let's think about this. 3 times 9 is 27. Minus 11 would be 16. 16 to the 1/2 power is the square root of 16, which is 4, plus 5. is 9. So x equals 9 is a solution. Let's try 4. I'm going to see if 4 is equal to 5 plus 3 times 4 minus 11 to the 1/2 power. All right, 3 times 4 is 12, minus 11 is 1, the square root of 1 is 1, and 5 plus 1 is 6. Well, 4 doesn't equal 6, so 4 is an extraneous solution. Okay, let's go ahead and try number 12. I've got to isolate my radical, so I'm going to add n to both sides. So n minus 3 equals 37 minus 3n to the 1/2 power. So I'm going to square both sides to get rid of that 1/2 power, that radical. N minus 3 squared would give us n squared minus 6n plus 9 is equal to 37 minus 3n. Move everything over to the left where our n squared is positive. So this is n squared minus 3n minus 28 is equal to 0. So factors of negative 28 that add up to negative 3 would be n minus 7 times n plus 4. That gives me the solutions n equals 7 and n equals negative 4. Let's check those. I want to know if negative 3 is equal to 37 minus 3 times n, so 3 times 7 to the 1/2 power minus 7. All right, 3 times 7 is 21. 37 minus 21 would be 16. 16 to the 1/2 power is 4. So is negative 3 equal to 4 minus 7? It is. So n equals 7 is a solution. Let's try n equals negative 4. I want to see, does negative 3 equal 37 minus 3 times negative 4 to the 1/2 power minus negative 4? Okay, negative 3 times negative 4 is positive 12, so 37 plus 12 is 49. The square root of 49 is 7, but this minus minus turns into a plus. So negative 3 does not equal 7 plus 4, so n does not equal negative 4. All right, this is going to be our last one. We're going to cut number 13, and we're going to skip right on to 14. Okay, looks a little different. Our x, or our variable, isn't under the radical, but we're still going to work it the very same way. So I want to get all my x's on the same side. So I'm going to get that 18 is equal to x root 2 plus 3x. Now, in order to solve for my variable, I've got to get it isolated. And right now it's in 2 places. But that just means it's a common factor of these 2 places. So what I have to do at this point is pull out my GCF of x. And what that gives me is x times root 2 plus 3. So what I did there was pull out the GCF of x. Okay, now I'm going to divide both sides by root 2 plus 3 to isolate my x. So I get that 18 over the square root of 2 plus 3 is equal to x. Well, that's great, but my answer is not fully simplified yet because I have a radical in my denominator. So what I'm going to have to do is multiply by the conjugate. And remember that the conjugate would be root 2 minus 3 over root 2 minus 3. So I'm going to continue down here. I would get 18 root 2 minus, let's see, 18 times 3 is 54 over root 2 times root 2 is 2, and negative 3 times 3 is negative 9. So that is 18 root 2 minus 54 over negative 7. That is my x value. Nothing can reduce because nothing goes evenly into 18, negative 54, and 7. Now I want to point something out. Some of you, if you were working ahead, you might have factored out the 3 plus root 2 instead. So you might have used a conjugate of 3 minus root 2. And you would have gotten the same answer even though the signs look a little different. This answer is exactly equivalent to negative 18 root 2 plus 54 over 7, which you might also see as 54 minus 18 root 2 over 7. Sometimes, because every single sign is different, those terms are exactly the same. Those are equivalent. Okay, so that's the end of your notes. You're now going to start on your homework and try and get as much done of it as possible. Have a great day, and I will see you tomorrow.